Shouldn't the switch and the that thing kind of be in a series? Like,
which two things?
if you go to the picture quick, if that's easy, you know, that's a big deal.
I don't know if it is.
Okay, so see.
Oh yeah, so the switch is here.
Yeah,
instead of there.
Isn't that just like parallel now? So the way you have it set up?
No, this switch is still in series with where that one was. It's the same thing.
I don't know. I'm talking about the other one. Like,
Yeah, these two are in parallel. That's true.
okay.
So they're supposed to be in parallel.
No, but don't you have like this one hooked up on the thing like bam to like straight instead of having it go like, you know, like
Same thing for everything.
I don't think so. Let's look. If I do it, it's the same thing. It looks a little different. It's the same thing.
Same thing.
It might look a little different, but it's the same idea.
So I was not as smart as the rest of you.
It's all good. It's all good. So here we are. I'm going to turn on the circuit, and we see electrons flowing up to the light bulb, up to the fan. I'm going to put some current meters on there. Now watch when I push this button what happens to the speed of the fan, and you can watch the speed of the electrons in the circuit here. It's kind of interesting. Right now there's 1.2 amps flowing through the light bulb and 1.2 amps flowing out of the battery. I'm going to push the green button.
Push it.
The fan speeds up. And if you look at the currents, they're working correctly yet. Let's try it again. The current out of the battery is like, you have to believe it, the current in each branch is the current out of the battery.
I don't see anything.
What just happened?
The video ended abruptly.
Oh, okay.
So why does L1 get dimmer when I push S2?
So there's an
Easier path. So now you have the same potential difference, but less resistance, so you're going to end up with a lot of current going this way. And the battery, if the battery was like an infinite current source, this bulb might stay lit up, but this fan is going to limit the total current through the circuit. So they're going to split up proportionally from there. So the battery can only give so much current because the fan only lets like 0.6 amps through it. So that's all that can really happen overall. If there's no fan, L1 would stay lit when S2 is, or would it stay lit? And the answer would be no, because now we have what's called a short circuit. If there's no fan here, I press S2, that's a direct path from the negative to the positive, that's always bad.
Wait, oh.
Okay.
Like if there's no fan.
If there's no fan, this wire is up here, and I press S2, then we have what's called a short circuit. And so the current would just fly right back up to the top with nothing to stop it.
Why is that?
Because your battery drains really fast because there's no
Oh,
resistance.
so that's like not putting a light bulb on.
Correct.
Just like putting it to
Mhm.
If you do that with
But wait,
jumper
didn't we-
cables in a car battery, you can melt over a battery.
Didn't we do that at the beginning of like when we learned? Oh no, we didn't.
Light bulb. Now I think, I remember this class, Pat, did you burn yourself on the first day of the chapter?
No.
Okay. Some people in our classes did it poorly and they held the wire inside the battery and they got burned because there was a short circuit.
Gotcha. Okay.
So if you want to try it at home, you could.
No, I'm good. I'm good.
So now the switches. This is the first switch. You press either of the green ones, the light turns on. Neither, it does not turn on. Both turn on, so call it this or that. I can press 1 or 2, and the bulb turns on. Project 9, we had two switches in series down there. So I pressed either one individually, nothing happened. If I pressed them, neither of them, nothing happened. If I pressed them both, the light turned on. So you had to press 1 and 2. There's a this and that switch. Duh.
It's a series.
I'll get this and that.
The last two, you mean?
Yeah.
Okay, we'll go over it now. So right now, if I don't do anything, is light turned on?
Yeah.
Correct, because these are broken paths, so all the current's going to go through the diode there. If I press S1, the diode turns off, because now this S1 is the least resistive path. Current going out of the battery through S1, back into the battery. It's going to skip over the red thing, because different path.
What is that?
My dog scared.
Yes.
What is that red thing?
It's a little light. It's a little red light. It's an LED.
Oh, cute.
Thanks.
Yeah.
Additionally, if I press S2 instead of S1, the current will skip the LED and come back to the battery again. If I don't press either of them, we said the LED is going to be on. If I press them both, LED goes off. So it's similar to an OR circuit that I can press S1 or S2 to make light turn off. To turn something off, it's like a negative circuit to make the contraction, which is the word OR, negative. That becomes this nor that. That one, I think, makes a little bit of sense. The last one is a crazy word in it.
Oh, I don't like this. No, I.
So on this one, if I press S1, light stays on. S2, light stays on. Press neither of them, light stays on. Press them both, light turns off. So I can press both switches to make something negative happen. So it's this and that, but you make it negative with an N. It's a special physics word, NAND. So whenever you have to press two switches to turn something off, that's going to be this NAND
Why does
that
that
circuit.
turn off?
What?
Why is that turn off?
If I press both of these, I now have a complete path over here. The green has less resistance than the red does, so the current's going to skip over the diode for the most part and go back to the battery.
And you put the resistor in there. it
So
goes-
why does that?
We don't want a short
off?
circuit.
Yes.
What's
That
that?
just, it'll short circuit it.
Essentially, it's not a true short circuit. We put a resistor there to prevent it from happening.
Okay.
But the
So
current,
you're saying that the more current would be going through the green than the red?
when I press both these switches, correct, the vast majority of like 99% of the current will go around the red
And
thing.
so that's why it doesn't light?
Correct. And a diode needs a certain minimum current to make it light up. So even if there's like a little trickle through here, it's not enough to make a light.
But with the electron still pass through it.
There's still going to be a couple of trickling through here. Okay, that is the end of that. Questions about snap circuits? Okay. You don't have to.
No, I do, because this game is.
Well, but you don't need to like it. I mean.